Hi guys, so this is your first notes from Unit 1, Lesson 1. Hopefully a bunch of it is review, but we're going to be talking about properties. So let's just go over a couple of vocabulary words so that we make sure to use the right words while we're working on properties and while we're talking about our numbers. So let me scroll this just a little bit. Alright, so on your page it says vocabulary. So we want to review when we say the word opposite, what that means, and that's going to relate to one of our properties. So the opposite of something really means the opposite sign of something. So to make that more formal, let's write it this way. The opposite or additive inverse. And there's the properties that we're going to be talking about as well of any number. And we'll use a variable for any number we want. So let's say n for number, is negative n. Okay? So really it's just saying that a number and then the opposite side of that number, positive and negative, they're opposites. And we're going to relate that to our inverse property that we're going to be talking about down the road. So then reciprocal is the same idea, except it's going to relate to multiplication and division, kind of. So reciprocal, you guys know what it is, but let's think about it more mathematically. The reciprocal or multiplicative inverse of any non-zero number, and instead of n, let's just use m in this case, is 1 over n. Okay, so it's a number and then it's fraction. You guys know that reciprocal means to flip. The bigger thing that we want to remember is the fact that they're called inverses in Algebra 2, because that's one of the properties we're going to be talking about. So if that's the number we're starting with, the reciprocal or multiplicative inverse is when we flip it, okay? And you guys know those, but just to make sure that we're all starting off on the right foot, okay? The next part we're going to fill out, but we're not really going to practice. Just that way, if we use some of these words down the road, you're following it, but it's not something that you have to know that, like, you know, that's going to be on an SOL problem or something like that, but it will help with all of us being on the right track when we talk about all of this math stuff. So that's this next part, subsets of real numbers. So right now we're talking about real numbers. Down the road we're going to talk about imaginary numbers. But real numbers are broken into different categories. So it says the real numbers consist of the rational, which means there's the word ratio in the word rational. So, okay, numbers and the irrational numbers. Okay? And when you think of rational and irrational, rational has the word ratio in it. So if you can make it a fraction, which remember, we can write fractions we can write ratios as fractions. So if you can make a fraction out of anything, then it's rational. Okay, it can make a ratio. And then if you can't make a fraction out of it, it's a decimal that just continues with no pattern or anything, that's what we would call irrational. Alright, then it says two subsets of the rational numbers are, so subsets meaning within rational, okay, we've got groups inside of that. And so the two groups inside of rational are whole numbers okay, and that's just regular 0, 1, 2, 3. It's like, so a lot of times we call them natural numbers or counting numbers because like when you count things like desks in a room or students in a class or something, you just count from, you know, how many do I have in whole, and you don't have negatives and times like that, and integers. Okay, and integers are like whole numbers, except it's the whole numbers and their opposites. So it's the negatives as well, like, you know, when you owe somebody $5 or something like that. So, so there's a couple more definitions under there about rational and irrational, but really it's, if you can write it as a fraction, even if it's a decimal, if you can rewrite that decimal as a fraction, it's rational. And then if you can't, it's irrational. And then under rational, there are two other categories within that. So that way, if we use some of these words, we'll all be on the same page, okay? The next part, the example 1, you don't have to worry about. We care more about going on into the properties. So, if we were to scroll down, okay, this section right here, you can just cross it out. We don't need to do this part for now. Okay, put it into your calculator, put it on the number line. We're good with that. We're going to keep going through some other stuff. Hold on one second. Alright, so here are some properties. The properties of addition and multiplication. And this is not to be crossed out. So let's erase that big X. This is what we want to talk about. Let A, B, and C be real numbers. Again, we're talking about real numbers right now. They're numbers that you'll actually use. And so this is the rule for the property that we haven't written down. A plus B is a real number. Since we're talking about real numbers, when you add real numbers, you get a real number. And when you multiply real numbers, you get a real number. So the property we call that is the closure property. And that just means if I put in real numbers, I get out real numbers. Okay, that's what closure means. It means the answer is the same type as the problem, is what we started with. Okay? We don't see closure very much, but just in case. All right, commutative. Okay, if you think of CO, okay, that's what a lot of times I talk with my students. CO, I remember that as change order, or CO. So if we change the order, that's the commutative property. So if I take A plus B and I change its order, it's B plus A. Just like here, if I'm multiplying A times B, change its order, it's B times A. So that's how I remember that one. Okay, associative, okay, it's like an association, which remember, an association is a group. So if we are grouping something, okay, if we have a group, or even if we make a group, that's a lot of times how they like to do it on the SOL. If we make a group out of something, that's the associative property. So A plus B is one group, and then we remade another group, B plus C. Okay, A times B is one group, so if I remake a new group, it'll be B times C. Okay, so sometimes it's regrouping, and sometimes it's just grouping anything. If you didn't start with the group, you just group it, and that's associative. That's what I saw in a lot of practice SOL stuff, okay? Identity means that it's not going to change, okay? It's like the ID that you're given when you're born. You're given a social security number. That ID, that identity, will never change. So identity property, the ID, means if I start with A, I end with A, okay? So identity, no change to the term, we'll call it. Okay, so whether it's a variable or number or a combination, that does not change. So if you add 0 to A, you get A. Okay, you could also go in the other direction. Okay, where you're adding 0 to A, you still get A. Okay, the identity is showing us that A is still A. And A right here is still A right there. Okay? So the same thing here, except under multiplication, instead of adding 0, we multiply by 1. That way that 1 won't change it. So I start with A, I end with A. So here, even though the order could be switched, 1 times A, you still start with A, which is your term, you end with A, which is your term, okay? So that's the identity property. And then the inverse, we've already talked about inverse a little bit. Inverses are opposites or reciprocals, okay? So here we have opposites. Here we have reciprocals. Okay, inverse, to invert something means to flip it, to make it upside down. So that's really helpful for the fractions, the reciprocals. And then when things cancel out, that's how I think of it. Any kind of canceling out is an inverse property. So a positive A and a negative A, they're the same number but opposites, they cancel out to 0. Okay? A number and its reciprocal, when you multiply them, they're going to multiply to the number 1. And that's just, that's the way that reciprocals work. If you were to multiply 2/3 and 3/2, anything like that, that'll multiply to a 1. It cancels out. So additive cancels out to 0, multiplicative cancels out to a 1, okay? So these are our general properties that we're going to be talking about, practicing that kinds of stuff, with some ways to hopefully help remember it. So, let's talk about probably some of the easier properties that I know most of you guys still remember because we use it so much. Okay, that is the distributive property. Okay? And the cool thing about this is that it talks about how the distributive property uses addition and multiplication. It's the only one. But most of you guys remember that to distribute, you just hand out or you multiply the A to both of these. Okay? So you multiply the A to both of those, and that's distributing. Most of you guys are fine with that. So, let's see. Identify the properties. So just ask yourself what's going on. Okay, we've got a group around 6 and 3, then we've got a new group around 3 and 2. So since it's grouping, that's the associative property. Of what operation? We're just multiplying. Okay, then here, what are we doing, or what's happening? 21 and negative 21, they are opposites. And opposites are also called inverses. So this is the inverse property of, we're adding those two, so addition. Okay? So that's just, you just go back to look at the list and what is it, what's the difference, what's the change, and that's how we relate that. Okay? Alright, so you don't need to do this next part. Okay, this next part is going into decimals and fractions again and putting them back into a number line. So you're done with that. Identify the property that is 10 times 6 plus 8 equals 10 times 6 plus 10 times 8. So what property is that? Most of you guys recognize what's going on right here. It is the distributive property. Okay? And again, because distributive multiplies and adds, you don't have to say addition or multiplication. It's just distribute. It's on its own. Okay? Alright, so let's go through on this last part. And let's talk about subtraction and division. Okay? If you notice, our properties were only addition and multiplication. And that's because subtraction and addition are just, they're kind of spin-offs from addition and multiplication. So, subtraction is defined as adding the opposite. Okay? If you take something away, it's the same thing as adding an opposite. Because when you do an opposite of something, that's taking it instead of adding it, okay? And then we also, again, just to reinforce it, the opposite, or, what did we call that? We called it the additive inverse, okay, of any number b is negative b. We used n of above. Same idea though. They're opposites. One's positive, one's negative. Okay? If b is positive, then the opposite of b is negative, and then we can switch it the other way. Okay? This is a little bit more confusing. You really don't need that part. Just one's positive, one's negative. Okay? So we can change it. Instead of a minus b, we can say a plus negative b. If we change subtraction to addition, then we can relate our properties again. We can use the commutative property, we can use the associative property. So even though there is subtraction, if you relate it to addition, then we just keep going with our properties. So division is defined as multiplying the reciprocal. Okay, and we know that reciprocal means we flip it. So, the reciprocal, or, again, it's an inverse, but in this case it's the multiplicative inverse, okay, of any non-zero number of b is 1 over b. We flip it, okay? So, for an example, I really don't like this because it's just so many letters and stuff. What you can really think of it as is like, let's say we have 10 divided by 2. 10 divided by 2, we're dividing right there, okay? Well, that means the same thing as 10 times, and what's the reciprocal of 2, or the multiplicative inverse of 2 is 1/2. Okay, these mean the same thing. This is how we write it in division, 10 divided by 2, but that's the same meaning as 10 times multiplying the reciprocal. Well, if you take 2 and you flip it, it's 1/2. Because if you do either one of these in your calculator, 10 divided by 2 or 10 times half, you get a 5. Okay? So this is the division. This is the multiplication of the reciprocal. Multiplying, and then we flipped it. Okay? So this right here is very similar to this right here. If you notice, the 2 is in the denominator for both. Okay? So let's use some properties to go through this next problem and relate it to what we're doing in the math and what the properties are saying. So let me scroll it just a little bit more. All right, and we are almost done after this. All right, so we're showing that we can start with all of this stuff right here, and we can end with a B. It's kind of like geometry, where we're starting with one thing and we're proving it, but we're going to do the math on one side and the properties on the other. So, the first thing we did is we started with the given. Get that out of the way. Okay? So this tells us that we're going to use the definition of subtraction. So we're going to take this subtraction and change it to adding the opposite. So instead of a 9, it's now plus negative 9. Okay? Then it's also telling us that we're using the commutative property. Well, CO stands for change order. So if we change the order, we're going to take these two and change their order. I'm going to put the negative 9 first, plus b second. Now that it's addition, now I can change their order. So the negative 9 comes in front, the b goes behind, okay? Then we ask ourselves, okay, well, what changed now? Originally, I had a group here, and now I have a group here. So my group is around something different. So the property that has to do with grouping is the associative property. Remember, an association is a group of things, a group of people or whatever that have something in common. So when we're grouping, that's associative, okay? So then, 9 plus negative 9, they are opposites, they cancel. So we get 9 plus negative 9 is 0. because that's the inverse property. When you've got opposites or when you've got canceling, you're going to get a 0. So right here, we cancel. That's how I know it's inverse. Inverse is canceling. Okay? And then what is 0 plus b? Well, if you add 0 to anything, it doesn't change it. There's no change. Its ID stays the same. We started with b, we end with b. So the identity or the ID of b doesn't change. So when there's no change, when we start with b and we end with b, that's why it's the identity property. Okay? So again, we got to kind of sift through those different things in order to get from one property to the next. But this is a lot of how you're going to see it. The math on one side, the properties on the other, so that you understand why we can go from one piece to the next piece, okay? All right, so the last thing we're going to do is we're going to go through this last one, and we have to make up the left side and the right side. So let's go through it one more time. And let's start it. We start with this whole piece. We need to end with an A. Okay? So we're going to start with our given. 5 times A divided by 5 equals, and then we're going to go from there. Kind of like the problem above. Okay? So this is our given. All right? So then in the problem above, first thing we did was we realized, okay, we don't have properties of division. So I need to change it. Okay? So division is the same thing as multiplying by the reciprocal. Okay, so division changes to multiply by the reciprocal. That way, instead of 5, it's 1 over 5. And that's our division. I'll abbreviate that. Or, excuse me, yeah, division, we'll say definition. Okay, the definition of division. We can change division into multiplying by the reciprocal. Well, that's convenient because now we have properties about multiplication. So now we want to probably change their order so that the 5 and the 1/5 can come together in a second. So we next want to change their order, put 1/5 first or before A. That way these two are closer together. So what property says what property says we can change order, CO. Okay, that is, CO is the commutative property. And instead of being of addition, it's of multiplication this time. Okay, it's of multiplication because we're multiplying between those. Now, I want to get these two together because 5 times 1/5 will cancel out, which is what we want in the end. So the next thing we have to do is say, okay, 5 times 1/5 instead of 1/5 times A. So instead of grouping those two, I want to group those two. So now that we have grouped differently, the property that has to do with grouping is the associative property. Because associations are groups. So since my group is around something new, that's my associative property. Now we can finish this out. What's 5 times 1/5? Well, that's the number 1. What happened to those two things? They canceled. This canceled out. So which property talks about canceling out? This number and its reciprocal cancel out to a 1. That's the inverse. Because it's the multiplicative inverse. 5 and 1/5 are multiplicative inverses. Then 1 times A, that actually doesn't change it. A stays the exact same. So that is our identity. So this proof, so again, this stays the same. Okay? So again, this proof is very similar to the one above, except it's multiplication, but we still have to shift things. We had to change to multiplication, we had to regroup, we had to change order in a different order than that. But that way we're understanding this is how we get from the beginning to the end, and this is y. Okay? So that's what we're going to be talking more and more about. That is how you're going to see it typically on tests and stuff, is that you're going to be given the math, and then you have to figure out, well, what's happening from line to line, okay? So I think that's it for this section.